Okay, we're going to start our video on applications of differential equations. So we're going to give you some problems that you may have seen before in pre-calculus or even algebra 2, but we're going to take the spin on it with calculus and figure out how to do these problems using calculus. There's 3 types of application problems that we're going to learn, 2 of them today. So let's just go ahead and tackle them. So for this first one, in exponential growth or decay, we assume that the rate of increase or decrease of a population at any time t is directly proportional to the population p. What that means is that the rate of change is, which means equals, so dp dt is directly proportional, which means that we're going to have k times p, where k is a relative growth rate. If you were to solve for this, you would actually just get this value right here, which you have seen before in pre-calculus or now algebra 2 with p equals p naught e to the kt. So let's go ahead and tackle a problem like this right here. And we're going to use our calculus here, and we're going to figure out that our solution will look kind of sort of something like that, and we'll answer the question. Okay. So the rate of change of y is proportional to y. When t equals 0, y equals 2. When t equals 2, y equals 4. And now what's the value of y when t is equal to 3? Okay, so since it's directly proportional, so the rate of change of y, which is dy dt, which is equals, directly, it's proportional to y, so it's going to be k times y. All right. So what we're going to do here is we want to do a real quick solve of this. So I'm going to divide this y over, so I'm going to get dy over y equals k dt. And then when we take the antiderivative both sides, do that in black, I'm going to get ln of y equals kt plus c. And then now I'm going to go ahead and start to use my initial conditions. So like before, I have solved for y for a little bit before I've done anything. I'll do that here as well. So let me solve for y real quick. If I raise the power e to both sides, I'm going to get y equals e to the kt plus c. And this is really just going to be e to the kt times e to the c. So I'm really just going to make that just a big, e to the c is a constant, so I'm just going to make that y equals c e to the kt, which is matching up my formula up here. So let's start to go ahead and plug in some of our givens. So our first one says when t is 0, y is 2. So let's go ahead and do that. So when y is 2, do different color here. So when y is 2, t is 0, so k times 0 is going to be 0. E to the 0 is 1, so c is equal to 2. So this is going to tell me that y equals 2e to the kt. So I solved for one letter. I need to solve now for the other. That's why I'm given 2 sets of equations. So now when t is 2, y is 4. So I'm going to go ahead and do that work right here. So y is 4. 2e to the, and then t is 4. 4k. I'm going to go ahead and solve for k here. So we'll divide by 2. I'm going to get 2 equals e to the 4k. If I write ln on both sides, I'm going to get ln of 2 equals ln of e to the 4k, which is just going to be 4k. You got to be you got to be sharp on your ln properties here. So k is going to equal ln of 2 all over 4. All right. What am I getting? 4? Oh no, why 4? What did I do wrong here? When t is 2. Oh wait, t was 2 the whole time. Oh my garage! This should have been 2 the entire time. I can't read. That should have been 2. That should have been a 2, and that's going to be a 2 as well. So what this is going to end up being is you can rewrite this as k equals 1/2 ln of 2, which is the same thing as ln of root 2. Okay, so now our final equation up here for when we plugged in these two equations is going to be y equals c value was 2, e to the k was ln of root 2, so ln of root 2 times t. So that's our equation that we found given these two pieces of information, as long as you plug in the correct numbers. And then it says what the value of y when t is 3. So all you can do is just plug in the 3. So y equals 2e to the ln of root 2 times 3. And when you do that, you would use your handy-dandy calculator. So you just pull out your calculator, go ahead and use it. Just for the sake of time, I'm not going to do that because we all can type that in if we really wanted to. You're going to get an answer of y equals 5.6568. Again, you're going to round to the 3 decimal places. You can either truncate or round it. Doesn't matter. I'm just going to write 4 just so that it can be a little more accurate. And there you go. So this one, not so much of an application, but just kind of telling you a little bit about what's going on here. So it's not like a word problem. We're going to get that coming up next here, but it's more of a here's some information, solve this. But here we'll get a actual word problem that'll put this a little bit into perspective here. So suppose that 10 grams of plutonium isotope Pu-239 with half-life of 24,100 years was released in the, I can't read these words, Chernobyl nuclear accident. How long will it take for the 10 grams to decay down to 1 gram? All right, so you don't mind, I'm actually going to go to this point right here. Right here. Okay, so I'm going to go to right here because I could do the same exact idea here, starting with our proportional rate and everything. So I'm going to start with y equals c e to the kt. All right, again, you could go through all this work and get the exact same thing. I just want to show it the first time around. All right, so now what are we given here? So we are being told that we have 10 grams, and so c is the initial value. So just like when t was 0 over here, we found that c was actually 2. So our c value is going to be 10. Okay, so that really helps us out a lot. And then, so we're going to get y equals 10 e to the kt. Now, I actually need to solve my k value, and that's where this information is going to come right here. Half-life 24,100. Half-life means that y is going to be 1/2 when t is 24,100. So I'm going to go ahead and plug in those values so that I can solve for k. So we have half of it remaining. All right, so actually, no, sorry, y is not a half. Half-life of 10 is actually 5. So let me get this. It'll be 1/2 in just a second. E to the 24,100 t. Get a little ahead of myself here. I'm still thrown off by this too. So y is 5 because it's 1/2. So when I divide the 10 over, this is where you're going to get the 1/2. When you divide that 10 over, you're going to get 1/2 equals e to the 24,100 times t. There you go. So it takes half, starts at 10, half-life takes 5, it's going to be 5 grams remaining in this many years. So this is actually should not be times t, this should be times k, and I already see more boo-boos I made. So this should be a k, it should be a 0, and this should be a k as well. All right, now I actually got this straight up now. Okay, so now I just got to solve for k. So I'm just going to divide both sides. Well, I got to get the ln. I got to get this k down first before I divide. So I'm going to ln of 1/2 equals 24,100 times k. Now I divide it over. So I'm going to get ln of 1/2 all over 24,100, and that's going to equal k. Yeah, I'm going to find that k value. I'm going to plug that in, and I'm just going to just store that. Let me do that real quick for you. Just show you how to do that. So I'm going to do ln of 1/2, and then divide that by 2,400. And that's going to be that value right there. If you actually hit this STO button down here, You can store that. And if you use this green alpha button, you can pull up one of these green letters. Let's pull up K. So instead of rewriting this every time, I'm just going to use the letter K just for convenience because I'm telling you what K is. So now I'm looking, so I have K, I have everything now. So how long will it take for the 10 grams to decay down to 1 gram? So that means that, and this is the part where I answer the question. So I'm down to 1, started with 10, e to the, and in this case, I don't know my t value, so make that t times k. And I do know k. K is this number that was on my calculator. So I'm going to get 1/10 equals e to the t times k. I'm going to ln both sides. Give myself room, and I'll do that up here. ln of 1/10 equals t times k. And then so t is going to be equal to ln of my 1/10 all over k. And then when I do that on my calculator, go ahead and do ln of 1/10 and then divide that by my alpha k right there. Boom, there's my answer. So that's going to give me my t value there, which is going to be t equals 79726.274 years. Okay, so this is just using a decay problem. All right, so I said there's 2 types that we're going to be doing today. There's 3. So we just did exponential growth, decay. That's really just 1 type. And let's go ahead and do our last type, which is Newton's law of cooling. So the rate of change of the temperature of an object is proportional to the difference between the temperature of the object and the temperature of the surrounding medium. So the dt, big T, stands for temperature, little t is time. So d big T all over dt is equal to k times big T naught, which is the original, minus big T sub s, which is the surrounding. Okay. So suppose a room is kept to a constant temperature of 60 degrees. That's going to be the surrounding. So T sub s is equal to 60. And an object cooled from 100 to 90 in 10 minutes. How much longer will it take for it to cool to 80 degrees here? So using this formula right here, dt over dt equals k times big T minus T, and this is going to be 60, the entire problem. That's not going to change. Okay. So now I'm going to go ahead and solve for this differential equation. So I'm going to divide that over. I'm going to get dt over t minus 60 equals k dt. Integrate both sides. I'm going to get ln of t minus 60 on both sides equals kt plus c on the right side. Okay. You can solve for this t. It doesn't really matter. Everything's going to be positive, so this absolute value is not going to matter. So you could actually start plugging in right away. I'll do that right now. I'll just start plugging in just to save a little bit of time. So we have the temperature cooled from 100 to 90 in 10 minutes. Okay, so how much longer will it take? So at t equals 0, the temperature was 100. T equals 10, the temperature was 90. So this is what that's telling me. So I want to plug in this first statement because I can get rid of the k value to find my c value. So ln of 100 minus 60, which is 40, which I don't know the absolute value at this point, equals k times 0 plus c. So c is going to equal ln of 40. Awesome. So I'm going to get ln of t minus 60 equals kt plus ln of 40. All right, so now I'm going to go ahead and use this second statement right here, and then I can go ahead and find the k value. So what I'm going to do here is ln of 90 minus 60 is 30 equals k times 10 plus ln of 40. So I'm going to get ln of 30 minus ln of 40 all over 10 is equal to k. So you would go ahead and type that into your calculator. I won't do that, so I'm going to save a little bit of time here. So we have the k value. Now, how much longer will it take for it to decrease to 80? So now I want to find out my t value when, my little t value, when my big T value is 80. So now I have everything. So I'm going to get ln of t minus 60 equals this kt plus ln of 40. In this case, t is 80, so we're going to get ln of 20 equals, again, I stored the k already, so kt plus ln of 40. Subtract that ln of 40 over and divide by that k value that I stored in my calculator. And then I'm going to get an answer of 14.94 minutes. Okay, so this is a very calculator heavy problem. I didn't want to spend too long doing that because you all can figure out how to do that on your own.